This is the 17B video. Today we're going to introduce light. So any of the other announcements that you need to see, just check that introductory video. So the big question for today is, could someone drive so fast that they never encounter a red light? Remember, there are codes in video. One is written, the other is verbal. And just write what's in green. That is what you need in your notebook check. So this is the 17B written code. I recommend you write this down somewhere. So we started off this day with the double slit experiment, and this is what you should see when you have the double slit experiment. You're going to see this interference pattern, and that is because light is a wave. So that is what Newton came up with when he used the prism, and he was the one that identified Roy G. Biv and said that white light is all the other lights combined. Now, William Herschel recreated Newton's prism experiment. He noticed that red light produced more heat. Now, he did this, and he put the thermometer just beyond the red light, and he noticed that the temperature went up. So he was the one that came up with the he's the one that discovered that there's more to the light than what we can see, and that introduced the electromagnetic spectrum. Now, electromagnetic waves differ from mechanical waves in that they do not require a medium to propagate. This means that the electromagnetic waves can travel not only through air and solid materials, but also through the vacuum of space. So the electromagnetic spectrum is a range of all types of electromagnetic radiation. Light waves are forms of moving energy that made of particles called photons, and light waves are transverse waves. So why is glass clear? So to do that, we have to understand what color is. So if you have a white surface, it's going to reflect all the different colors of the light in the white, and you're going to see that white light. Now, if that is a black surface, it's going to absorb all those lights. Now, if it's something like red, it's going to absorb everything but red. Now, this happens on an atomic level. Now, absorption and reflection are just if those frequencies, those energy of light, basically ionizes or quantizes these or energizes these electrons. So that's what absorbs it. It takes a photon to energize these electrons up to the next energy state. And if it's not the right energy or not the right frequency, it's not going to do anything to that electron. Like sometimes that electron will absorb it and re-emit the same one, but sometimes it re-emits a different one. It jumps down to another level. That's when you get like reflection and absorption. Now glass, the way that the structure is set up, those electrons don't really react to visible light. So visible light just kind of goes through it, but it does react to ultraviolet light. It needs a higher energy. Now, could someone drive so fast they never encounter a red light? So that brings us to the Doppler effect when we're talking about light. So if a body in space is blue shifted, its light waves are compacted and is coming towards us. If it's red shifted, the light waves are spread apart and is traveling away from us. And theoretically, if you were to drive fast enough, those red lights at a traffic light could appear green because you're blue shifting it. You're blue shifting it. Now, you would have to go incredibly fast. You have to go about 20% the speed of light. That's fast enough to travel around the world in 1 second. But theoretically, it could be done. All right, so at this time, I'll go ahead and give you the verbal code. It is 903. I say that again, the verbal code is 903. And as always, I'll leave you with this final thought. There's too much unknown in the universe to take a break from learning. Get out there and question everything.